Hey guys, welcome on Erratic Coder. In this video, we are going to talk about data types in Go language. So first of all, we need to understand what is data type. Suppose I need to fill this form. Here I need to give some information as name, address, city, phone number and so on. So here I am giving the name as Purnima. That is basically a combination of multiple letters. Letters is also a type of data. Here I am giving the phone number, that is a combination of multiple digits. Digit is also a type of data. In a similar way, we work on multiple data types in any programming language. In Go language, data types are divided into two categories. First is primitive, second is non-primitive. Primitives that are already defined by Golang creators, and second non-primitives that we programmers create in our program. Primitive data types are further categorized into multiple data types as Boolean, numeric, string, error, and non-primitives are divided into pointers, array, structure, slice, map, and channel. So here we'll cover every data type one by one, starting with the Boolean data type. Boolean data type can have two values, either true or false. As we saw in this form, we are providing the value of are you 18 plus question in terms of yes or no. Similarly, here we can consider yes as a true and no as a false. So any variable that is of a Boolean data type can have two values, either true and false. Next data type is numeric. As we all know, numeric is simply related to the numbers. In Golang, we can divide numeric data types in two categories. First is integer and second is floating point. Any real number is an integer that do not have fractional values. And floating point numbers are those real numbers that contain decimal point which is not fixed within a number. According to this number line, we can have infinite numbers, some are positive and some are negative. All positive and negative numbers comes in a category of signed integers, and all the positive numbers comes in a category of unsigned integers. According to the range, we can divide integers as uint 8, that is a 8-bit unsigned integer, uint 16, that is a 16-bit unsigned integer. Here the range of 8-bit signed integer is 0 to 2 to the power of 8, and the range of 16-bit unsigned integer is 0 to 2 to the power 16. Similarly, we can have unsigned integer of 32-bit having range of 0 to 2 to the power of 32, unsigned integer of 62-bit, signed integer of 8-bit, that is dictated as int 8, signed integer of 16-bit, signed integer of 32-bit, and signed integer of 64-bit. Now we'll see how to declare these type of data types in Go language. To declare any variable in Go language, we use var keyword. So here I am trying to declare unsigned integer of 8-bit. Here I am using var keyword. Val1 is the name of the variable that is of type unsigned integer 8-bit. If I am saying that this variable is of type unsigned integer of 8-bit, that means this variable will contain the value of 8-bit unsigned integer. Similarly, here I am declaring 16-bit unsigned integer, here 32-bit unsigned integer, and here 64-bit unsigned integer I am using. If I run the program, then it will provide us the value of all four variables we have in our program. The range of 8-bit unsigned integer is 0 to 2 to the power 8. That means 0 to 128. Suppose I assign 300 value of type 8-bit unsigned integer and run the program. It will throw an error as constant 300 overflows unsigned integer 8. Because the maximum value in unsigned integer 8 we can have 128, and I am trying to assign 300 in this variable. So it will throw overflow error. This is the declaration of unsigned integers. Coming to the signed integers, we have 8-bit signed integers having range of -128 to plus 127. That means minus 2 to the power 82 plus 2 to the power of 8. Next, 16-bit signed integer, range of minus 2 to the power of 16 to plus 2 to the power of 16. Next is 32-bit signed integer, and the next is 64-bit signed integer. Let's see the declaration of signed integer in Go. This is the declaration of signed integers. Here I am declaring 8-bit signed integer as a variable of val5, declaring val6 as a 16-bit signed integer, val7 as a 32-bit signed integer, and val8 as a 64-bit signed integer. As I told that signed integers can have a negative as well as the positive values. So here this variable contains negative and some are the positive values. We are run this program, and here is the output. Here I am assigning this value to 16-bit signed integer variable. If I change the value and run this program, error is of overflow in 16 because this value crosses the range of 16-bit signed integer. Other than signed and unsigned integers, we have complex numbers in integer category. Complex numbers is a combination of real and imaginary part. Here x is a real number and iy is considered as an imaginary number, where y is an imaginary part. In Go language, we can have complex number of 64-bit and complex number of 128-bit. Let's see the declaration of complex numbers in Go. Declaration of complex number is same as signed and unsigned integers. Here we are just changing the type of this variable. We are taking the type as complex 64 and the complex 128. I am declaring variable val9 as a complex 64-bit data type and val10 as a complex 128-bit data type. Let's run this program. Here is the output. So this is all about integer data types. Let's jump to floating point data type, where we have float 32, float 64, complex 64 and complex 128. As we saw that any real number that contains decimal point which is not fixed within a number is a floating point numbers. Let's see the declaration of all these data types: float 32, 64, complex 64 and 128. Here I am declaring floating point integers by using float 32, float 64, complex 64 and complex 128 data type. Let's run the code. We can see complex 64 and complex 128 in both the categories of integers and floating point numbers. The difference is, in integer category, the real part of this complex numbers is integer, and in floating point category, the real part of this complex number is floating point number. Other than integer and floating point numbers, we have byte and rune in numeric data type category. Byte and Rune both are alias of integer data types. Byte can be considered as unsigned 8-bit integer and Rune can be considered as 32-bit signed integer. Byte and Rune both are used to identify character values in Go language. Byte specifies ASCII characters and Rune represents Unicode characters. Any character, if we are not declaring its type, then it is considered as a Rune. Let's see the declaration of Byte and Rune in Go language. Suppose we have a variable var11 and here I am assigning value a. Here let's check this the type of var11. So here you can see the type of this var11 is int32, and as we told that Rune is an alias of integer 32-bit. So we can say that any character, if we are not declaring the type of this character, then it is considered as Rune. Similarly, I can declare byte here I am taking variable as var2 and here I am using byte keyword to declare this variable as a byte, and I am assigning b character here. We'll try to print the value of variable var12. Parallelly, let's check the value of variable var11. Okay, print ln. So here we can see the value of var12 is 66. That is basically the ASCII value of character B, and the value of var11 is 65. And here the difference between byte and rune is byte represents the ASCII values, whereas rune represents Unicode values. To declare rune, I can give rune here and I can assign any character. Suppose I am assigning tilde here. Now let's check the type and value. So the type is it's tilde int 32 and the value is 126. So here Unicode value of this tilde sign is 126 and the value of ASCII value of character B is 66. So this is rune and byte. With byte and rune, we are wrapping up numeric data type here. After numeric, another primitive data type is string. String is nothing but this is a combination of multiple characters, and in Go language, each and every character of a string is considered as a byte. So we can say that in Go language, string is a collection of multiple bytes. Let's see how to use strings in Go language. I have a variable var13, and here to declare this variable as a string, I am giving as a string, and the value of this string variable is erratic coder. Let's print the value of this variable var13. So here is our output. Here is another way to declare the string without using this string keyword here. So by using this colon, we can declare as well as assign any string type of the value to any variable. So this is another way to declare the string. Okay, we have to remove var here. Cool. In Go language, it is necessary to declare the strings in double quotes. Suppose I put single quote instead of this double quotes here and run the code. It will throw the error more than one character in rune literal because Go compiler considers the characters in single quote as a rune. So that's why it is throwing error as more than one characters in rune literal. Here I am taking a single quotes, that means it is considered var14 as a rune data type. So it is necessary to declare any string in double quotes in Go language. Let's jump to another data type, error. In Go language, error is a built-in data type. By default, any variable that is of error data type is nil, but it can have any type of the value. It totally depends on the situation where we are getting an error. Let's understand an error data type with an easy scenario. Here I have already copied the code, and in this code I am trying to read a file from this path. I am using OS module, so firstly I have to import it. So while reading this file, it will return two values. First is the file content and second is the error if we get something. So if we get any error while reading the file, it will return the error value in this variable, otherwise this value will be null. Let's run the code and see what is the value of the file and the error. So basically, we are not getting any data in file. and an error is no such file or directory. Let's find the type of this ERR variable. Type of error is run the code, and here the type of error is path error. So we can clearly see that here the type of the error is path error and the value of the error is no such file or directory. So this is the use of error data type in Go. So in this video we have covered primitive data type as boolean, numeric, string and error. In next video we'll cover non-primitive data type, pointers, array, structure, slice, map and channel. If you guys want the complete code I have explained here, then you can check the blog of this topic. I have mentioned the blog link in the description, so you can get it from there. Let's cover the non-primitive data types in our next video. Thank you.